I am here to introduce my friend Beth, Dr. Elizabeth, the other Dr. Elizabeth Minot, very hard to say. She is a distinguished professor in the College of Computing and the executive director of Georgia Tech's Institute for People and Technology, or IPAT, not iPad. In her research, Beth directs the Everyday Computing Lab, where she investigates the design and evaluation of health information technologies. Some of these things help breast cancer patients with their journey. Some of them, this is good for a post-lunch talk, address positive and negative influence of social media on self-harm behaviors such as eating too much, eating disorders. Minot is the past chair of the Computing Community Consortium, so she is Mark's predecessoress, if that's a word. She serves as a member of the National Academy's Computer Science and Telecommunications Board, CSTB, and as an ACM Council member at large, and lots of other things. She's been recognized as an ACM Fellow, a member of SIG Chi Academy, a Sloan Fellow, I didn't know that, and Kavli Research Fellow. Lots of other awards, including Top Woman Innovator in Technology by Atlanta Woman Magazine. So please welcome Beth Minot.
Yeah, once something goes on the web, it never comes off. So thank you, Liz. So neither of us actually go by Elizabeth, but Liz and Beth. But when we're in trouble, call us Elizabeth. I was asked to give this talk with very little constraints, including actually time, which I discovered later. So I'm going to try very hard to fit within the time constraints. But I designed this as a new talk, which means I'm having fun with it. And I suspect there'll be some rough parts, but I hope it is valuable to you. What I wanted to do was to take my opportunity as the past chair of the CCC and really 10 years of being involved in CCC activities to reflect on what it means for us to promote audacious visions for computing research. And as I adjusted my talk title, but did not bug Helen about it, audacious community visions for computing research. So I'm going to play with that as we go through. And so, of course, I did this the way one starts writing any fresh talk, which is to go out and Google and have some fun with it. So what do we think, what do I mean by audacious? And it's difficult probably for folks here to reflect, but this started over a decade ago. And at that point in time, the computing research community had a real reputation for being pretty insular. We were known for, as we say, kind of shooting the arrows inward as opposed to shooting the arrows outward. So we're really good at taking down each other's work. For example, on NSF review panels, we had a reputation for doing incremental research based on kind of the massive foundations that had come before us. And so Anita Jones, one of the founding members and designers of this thing that would be called the CCC, is the one that is credited with the idea that we, even though I don't think it ever officially was in the mission statement, that we were about catalyzing audacious visions. And this is going to turn out to be extremely insightful as we look at kind of the history of the challenges that then came after us. I did think it was funny that the other definition that immediately showed up in my search was showing an imprudent lack of respect, which I actually think our field also has a reputation for. And in some ways we've caused some of our own troubles, and I'll get back to that later. But reflecting on the slide that I suspect that you saw from Mark this morning, although I was on my second attempt to fly here, thanks Delta, this notion of audacious visions for research became incredibly important because what has happened during that decade plus has been a transformation of our field and the importance of computing no longer just about kind of the technology in the box or the technology associated with the computing industry, but more and more for the types of things that are being asked of us in terms of the future of health, the future of energy, the future of transportation. And so what we are being asked to do as a community is to play in the space of government and academia and industry to forge together a common path that can address so many societal challenges. And so that led me to my second definition, which was actually the least satisfying of all of them. So someone needs to fix this, but the definition of computing that is out there is completely sufferential, the process of using computer technology. Okay, thank you. And computing may involve computers. Thank you very much. And therefore, computer science is now the science, engineering, experimentation for creating computers. So this means to say that we have a lot of room to play in when we talk about what computing is, and this is something that we've embraced, but it was kind of fun to realize also that the historical definition of computer is a person who makes calculations, and that these individuals were almost always women before the computing technologies were invented. And if you reflect on our field, one of the things that we've seen is we're almost coming full circle on this, because computing is now being involved in more and more technologies and more tasks, and more women are involved. So I'm going to find some love for the definitions of computing in that. But this is the diagram that, again, with Anita Jones really thinking about audacious visions, this is credited to Ed Lazowska, the founding chair of the CCC, that really looked at, again, this transformation of the field as computing was moving from the what is in the box and how does IBM, for example, make lots of money, to, again, the demands coming to us. And I'm going to reflect on this a lot, that many of the things that the CCC has been challenged to do have been just as much people coming from the outside and saying, hey, you computing folks, can't you do something about, again, improving opportunities for scientific discovery, improving opportunities for energy, dealing with security and privacy issues that none of us foresaw coming, even Nadia, looking at a massive number of healthcare issues, including supporting an aging population. So I really embrace that we refer to ourselves as the computing community, and that computing is actually an expanding definition of the importance of the value and the challenges for our field. So I can see this, and I did not vet this with a single council member or the past chair, Greg Hager, sitting there, so he'll take me to task later. But this is my reflection of some of the key topics that CCC over the past decade has worked on, and I think you can see some of this evolution. So we actually started, for how many people here remember the Genie program? The future of networking? We spent a lot of time talking about how you could do networking research when this thing called the internet was out there. And so that was a very kind of inwardly focused discussion about how do we do networking research in the era of kind of the new network. And we also have had, subsequent reflections appropriately around post-Moore's law, around the future of systems and architecture. But again, those outside pressures have continued to knock on our door and asking harder and harder questions. So many of the kinds of things that we've been asked to do is, how do you unlock the power of X, where X is big data, where X is robotics, where X is AI, where X is the human brain. And many of the folks who want those doors unlocked are not computer scientists per se, but they care about the future of a particular field and domain, and they have an intuition that big data should be able to do something powerful for them. And can't you guys get organized around those types of challenges? And then that's been met by increasing challenges, some of them self-inflicted, on how do we then technically guarantee notions of reliability, correctness, security, and privacy and fairness. And in those cases, sometimes, program correctness is something that we, many of us have been taught and understand how to wrap our minds around. But a notion of a technical guarantee of privacy, a technical guarantee of fairness. Now we're talking the merger or the interface between technical systems and social systems, so we're talking socio-technical systems, and how do these things come together? And that creates some really wicked problems, informally stated, for our community. And then one of the things that I was really interested in, having been trained in human-computer interaction and having spent half my career trying to defend why HCI was actually part of computer science, some of us bear those scars, was that we were increasingly being asked how to make these systems more human-centered. And they didn't mean HCI per se. It wasn't about graphical interfaces or how things visually appear on a screen, but how do you make software-defined networking actually human comprehensible, match well with human tasks and human domains? We're hearing this pretty much in every single variant of the conversation of AI, and many variants of the types of Internet of Things or the different types of systems that are out there. So the demand from the outside, not necessarily met with complete receptiveness on the inside, was that these systems are now out there in the wild. They're impacting many lives, jobs, domains, for a bunch of people that have never had one class in computer science, and they want to know why these systems can't fit better, that's a technical term, why these things can't fit better within how people want to accomplish what they want to accomplish. And so the term human-centered has started to be wrapped around that. And so where these things seem to be going, and I'm going to talk about this a bit more in this talk as well as in an advertisement for the panel coming up, is that these are not only about, again, kind of human interaction with technologies, but now we're getting fun questions of, okay, well, if artificial intelligence is now eating everything, which is a fun phenomenon to watch, how do you make these systems evolve together? If technical systems learn, and if human systems, well, we know people can learn, how do they co-learn? How does a person learns how to use a new system, it's working from data, it's learning, but now people change. How does it learn in response to that? And how do you actually create that as a dyad, a person to machine? I learned a new term called centaurs, centaur chess. So these are the human-machine combinations, and the centaurs beat both the humans and the machine separately. And that you get really funny images when you Google that. But so that would be a dyad, but then how do we do this at a large-scale system, such, for example, as the systems of healthcare delivery that I work in on a regular basis? So with that reflection, and from this trajectory, I think it's important for then us to pick up some of the other C word and then talk about what it means to have community visions around this. So community was actually a pretty satisfying definition out there. We're a group of people with diverse characteristics who are linked with multiple different forms of ties. We share some common perspectives, but differ in others, and we engage in some sort of joint action, and at least say in terms of shared settings and sometimes shared geography. And I've never heard of this TV show, but that came up as a second hit. So if anyone's ever watched this, apparently it was good. But for us, community has met how we've instantiated that is recruiting, coercing, convincing, no blackmail yet, but bringing in, oh, has there been blackmail involved? Oh, okay. She's the chair of VICE, there we go. By pulling members of the community to come and serve on the council, to be stewards, liaisons, helping shepherd these audacious visions of the future of computing, and doing that by drawing smart, talented people who are already 100% busy, but nevertheless can answer to the call of serving on behalf of us. So first, I'm really thrilled that so many of the current council is here today, and for those of you who haven't had the opportunity yet, consider this the recruiting slide. But what we really want to do, it's really important that this not be one individual who thinks they have the answer, because there never is one right answer anyway. And it really, with deference to my NSF program manager colleagues here, is not just the question of kind of what one manager or project manager or someone at DARPA wants to accomplish. What we have found powerful is that when the community can actually come together and speak with that voice. And that's the process that we've worked on. So that leads me to the difficult term, and where I'll spend most of the talk, but this notion of shaping. Because shaping is an odd term, right? But this is not too bad of a definition. Determining the nature of or having a great influence on and giving it a particular shape. So still slightly self-referential. But this idea of how do you frame, how do you influence without having to be the one in charge? How do you pull things together? How do you give it form? How do you give it a recognizable form that other people can see? And for me, very much of what we do in the CCC visioning world, and I think what works when you're trying to convey this form of leadership, is this notion of shaping. I also think it like Audacious, I think it's ironic that the other definition that came up was essentially operant conditioning. So those of you remember your psychology class. So modifying behavior through stepwise reinforcement. And I think our field is actually guilty of this as well. And this is the death by 1,000 cuts, right? How have we eroded the public trust in computing through not being able to keep people's information secure, through not being able to create systems that protect people's privacy, by creating algorithms that are easily exploited because of the lack of kind of a full design process and a full diverse vision coming around this. So again, like Audacious, I think we are always shaping the expectations of what computing can accomplish as we go forward. And we can do the first version of this, which is to take this leadership role that is about having influence and shaping, or we can let things play out on their own, and I think we get much more of the latter. So what does it mean for us to instantiate this notion of shaping? So I think Mark maybe showed a version of this slide this morning, and this is very much the CCC playbook, right? So if we want to be shaping an audacious community vision for the future of computing, right? So you have to catalyze, you have to bring the people together. That's why we've brought all of you here. You need to then help articulate and communicate that vision. And doing so means bringing in a whole bunch of different stakeholders. And Peter's not here yet, so I don't get in trouble for facilitating investment, because we're not lobbying for resources, but we need people to buy into this because it does create greater opportunities and greater resources for the things that we want to accomplish. And then through that process, we need to create that leadership, right? It can't be Beth, it can't be Mark, it can't even be Liz, to be kind of the person in front of all of these visions, but it has to come from the community and it has to be led by the community. And one of the things that we realized was that not only was that a voice of kind of the senior leaders of the field, but it was incredibly important for us to engage quote unquote early career folks who will then continue informing and taking up those visions. And that's why you see so much of the emphasis of what we have done in the CCC around that as well. So I've talked, still got time, I've talked in kind of broad generalities. I want to give you a few examples of things that we've done in the past, and then give you a few examples of where I think we'll be going in the future, and encourage your dialogue and leadership to do that. So again, go back a decade. When the CCC started, here's an example, and I just want to show you what the playbook looks like, because you're going to be asked to continue to participate in these types of activities. So there was a curiosity around 2008 and before that maybe this notion of crunching data, this was before big data was big, but this idea of being able to crunch massive amounts of data, maybe that could provide some power in ways unforeseen. And there was especially an interest coming from the scientific community. So how could big data transform science? So what did this process look like? And again, we were inventing this on the fly then, but it's great to be able to look back 10 years later to see how it worked. So it was a combination of doing the framing, putting some positioning out there, putting out a white paper. In this case, the white paper was delivered to the incoming Obama administration. And from that white paper, then marshaling the community together in a number of different ways, the kinds of workshops that hopefully many of you have participated in, and then that series of white papers where that arrow is in the middle. And I want to reflect on that multiple times, because one of the things that's important about those series of white papers is it allows a set of diverse viewpoints around a common vision and a common topic. So not everybody is trying to squash into the same 4 pages, but you're able to understand how big data can transform healthcare, or how big data can transform geologic sciences, or how big data can transform security in completely different ways. And then that set of white papers gets walked around in some really fun ways, but it eventually forms an agenda that a larger set of stakeholders, again, many people without any training in computer science, have now embraced. And in this case, it was a combination of a set of federal investments that was the Big Data Strategic Initiative, and then that was eventually encapsulated into a strategic plan for the federal government. And Peter tomorrow may talk a little bit about what NIDRD is. But so that went from a genesis of, this should matter, to how do we pull a large number of people around to actually garner quite a bit of resources in this space and quite a bit of activity. Same playbook for robotics. In this case, I know how to point to Henrik Christensen as one of the leaders, but there had been some initial discussions. And again, you got to remember, a decade or more, there wasn't that much funding for robotics, and it was very scattered and relatively small in scale. And so this was an effort by the robotics community to come together, and again, workshops, again, the paper, again, the roadmap. But one of the tricks they did here, and it's also a trick that you see in the big data papers, is the papers were not about, okay, well, we need to handle sensing and perception, so we have a paper on that, and we need to handle articulation, and we're going to have a paper on that, and we need to handle mobility. So, because I've been around robotics conferences, or robotics hiring discussions are great. It's like, we have someone who can do hands, but we need someone who can do feet. I'm like, oh, HCI has got to figure out a way to organize itself like that. It wasn't organized by that. It was organized by robotics matters for manufacturing. Okay, here's that chapter. Robotics matters for healthcare. Here's that chapter. Robotics matters for transportation. Here's that chapter. So the roadmap took the fundamental concepts, the computing research that we need to do, and explain how advances in those would matter to a much larger community. So a couple more examples. This one's close to my heart, and I know my health buddies that are in the audience. So this was one of those where it was definitely the outside world came knocking to us. So again, new Obama-era administration investments around electronic healthcare records. So you guys remember when nobody had electronic healthcare records and we were all working with paper and fax machines? Now, we actually didn't solve all those problems, but now the adoption rate is 90+% for EHRs, and that was because there was a huge stimulus of funding that came into that. And some very wise people said, well, if we're going to spend all this money to change that foundation, wouldn't it be cool if we were actually doing research that was forward-looking that would take advantage of that new foundation? So in this case, the CCC was asked to organize and coalesce a new community, really, around the future of what we called health IT back then. That's not the sexy term anymore. But one of the tricks with doing that kind of convening was that the physicians and the doctors had to be, I'm looking at Tammy, they had to be at the table as well. And that took some really careful shaping because the computer scientists were really good in coming in and going blah, 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 and the doctors would quit listening because they were talking in a language that no one understood. And then the physicians would come in and do the same thing. And you had to blend those conversations in some really, really interesting ways. But what came out of that not only informed some existing programs, but came a new community and a new set of infrastructure and a new set of collaborations that didn't exist before. So that shaping is not just the words on the paper, but it's very much the people that are in the mix. And then my last reflection, but I love telling stories, is the same question was brought to us, but in this case it wasn't just health IT, it was a notion of, well, can't you computing folks, it was almost literally that, can't you computing folks actually do something about supporting an aging population? And the call came from NIH, but also the VA and from HUD, and they said again, CCC, can you pull together that community? We wrote the papers, we produced a workshop report. Lo and behold, we were really thankful that an entirely new funding program based on these concepts was then lost by the NIH. And to be fair, the NIH really didn't know how to think about this space until we worked with them on that, and that's why they asked us for that help. And then a few of us were lucky enough to also participate in an advisory report. So remember the last time we had the NIDRD strategic plan, this was for the Presidential Council on Advisors on Science Technology. And it asked the questions of, okay, if you can make this progress, so let's assume that can happen, what are the other barriers that stand in the way? And that gets down to things like policy and reimbursement and ingrained work practices. And again, that's another part of this shaping, right? The shaping is not just the words on the paper, it's not just the visions, but it's the people and it's the collaboration and understanding the barriers, because you have to address all of these issues to actually have the impact and the influence that you want to have. So I think I've made this sound a little easy, but in reflecting on the talk, I wrote down this list of what I think has been a bit of the ingredients. So there's been a perceived need, right? That we are at a crisis, whether it's an aging population crisis or a crisis with respect to the future of manufacturing, and there's a sense of a why now urgency associated with it. And sometimes that why now urgency is just because new resources could be on the horizon. And there's an intuition shared by a number of people, including researchers, that computing can play an important role, but if you look at the landscape, we've done a really good job of having a community that can be disconnected, that's not speaking with a clear voice. And I want to make this as obvious as I can, that when I say speaking with a clear voice, that's not a homogeneous voice. It's not just a one voice. It's reflecting the diversity of all of the approaches that are necessary to make progress in this space, right? It's not that AI for automation and AI for amplification, you need to pick one, but you actually need to figure out artful ways of combining that vision together. And then when you have those ingredients, it's a process for pulling the people together in the leadership around those voices and this vision, and then yet another process to bring other stakeholders, sometimes people with money, sometimes people with resources, sometimes people who just matter, to have, to sponsor and to buy into what you want to do. So now you guys are convinced that this is just easy, it's 1, 2, 3, and Beth has the recipe. Let me pose to you some of the topics that I think we are working on now, and I think we'll be working on in the future. And my challenge to all of you is to say, help us as a community understand how to wrestle with these. So intelligent infrastructure for our cities and communities. Dan's going to be talking about this in the next panel. We talked about those investments in health IT and electronic healthcare records. Well, what if we actually had major investments that everyone is calling for in terms of the future of our infrastructure that really affects every aspect of our day-to-day life? What would it mean to build in a research agenda that looks at forward-looking what intelligent infrastructure would look like going forward? So we're halfway through this process. We've pulled some of the community together. We have an awesome set of white papers that are out there. And that happened last spring. Earlier this year, we got to do a congressional briefing. And I love this picture of Nadia because she's talking about the need for security, and I think she's just scaring the hell out of them. So it was awesome. I mean, if you saw that face, wouldn't you be scared? Because she's like, you might want to care that these things are secure, right? Water systems, energy systems, transportation systems, it might matter. So I think this is one that is in play, but we're certainly not there yet. And I think it's a topic that matters, and computing has a lot to do with it, but it's not just computing, right? The future of air travel, the future, all of this, future of agriculture, those domains matter, and that input matters. We're going to be looking a lot now and in the future about the future of AI, and you're going to hear more and more about this. This is a conversation I really think it's important for our community to wrestle to the ground. In fact, there was a great editorial that's out this week of the media is being lazy and folks are letting them get away with that, right? It's really important that we shape the expectations around what these systems can do, what they can't do, and why they're worth investing in. And if we don't wrestle that conversation to the ground, then we're delegating that to someone who neither cares as much or is as technically competent in that space. 2 more slides. Likewise, we've learned a lot in the past decade that security isn't what we just thought it was a decade ago. And the technologies that we need not only to keep information secure, but to guarantee the processes that are fundamental to our society matter quite a bit. Kate Starbird gave an amazing talk at the Snowbird Conference, and I think really opened people's eyes about kind of where computing can play and what's going to be necessary, again, those interdisciplinary, multidisciplinary partnerships to move the needle in this space. And then advertisement for also a subsequent panel today around, I love that Target one. I hope everybody knows that story of Target's algorithms guessing that someone's pregnant and telling her dad before her dad knew. Not a good idea, bad marketing. Good algorithm. It turns out unscented lotion was the key. Who knew? We are counting on, in many ways, and this also relies on our partnership with industry, to create systems that are going to be involved in every aspect of decision making. Renting a home, buying a car, receiving a medical treatment. And those algorithms are being, in my opinion, designed way too much in a vacuum with respect to how they're going to be used, the larger socioeconomic processes around them, and the technical systems of how something puts out an answer and a recommendation, and how those recommendations are then fed into a very human, messy process. We have a lot of work to do at that messy intersection that makes HCI look really easy, because that human meets technology interface to this is complicated, but the technology folks are kind of running in terms of the horses have already left the stable, and we're going to have to grab that and shape that going forward, because we're either looking at a society that we're really not going to want to live in, or we're going to look at the abandonment of these approaches, which is also not going to lead to our benefit. So if I made it look easy in the first slides, hopefully I've convinced you of the challenge of the importance in the subsequent slides of what I hope we are able to do. So the one slide for the talk, work on catalyzing audacious visions for our community, for computing research, and help lead in shaping those visions to meet the needs of society. So thank you for your time. No time for questions.
There's no time for questions.
No, I'm kidding.
Well, time for one question.
Not Andrew.
Lev. No?
No, he's just running.
Okay, so
We're good.
Oh, please.
Thank you. If it's a zero question talk, it means I did something wrong.
So the question
Name.
is not directly related.
Amen.
The question is not directly related, but could you say a little? Oh, sorry. Oh, my name is Ifoma Wogu, and I'm from Rochester Institute of Technology.
Thank you.
So my question is about CCC, CRA, the relationship with NSF, and how we fit into and what we fit into in all of this.
Okay. CCC, CRA,
NSF.
NSF. Okay. NSF pays the bills. So CCC is funded through a cooperative agreement by the National Science Foundation, and it's actually not paid through CRA membership, but it's funded. We are funded by the NSF, and during my time on the CCC, I think I had worked with 4 NSF science directors, and what they wanted out of the CCC varied considerably. But it has been very much a reaction to the, how do we speak with a powerful voice for the computing community? Other more mature fields, physics, astrophysics, are really good at that because they have to marshal the community to explain why they need a beautiful telescope that's incredibly expensive and they're all going to share it. We don't share very well, so we don't tend to communicate in the same way. So, that's the blueprint, and then it varies kind of where we are in the federal and industry landscape about kind of the topics and the relationship of NIH and NSF and DOE, DARPA, and so on. The instantiation or the structure of that is to fund us as a standing committee of CRA. So just as CRA has CRAW, CRAE, and I'm forgetting the other pieces, but and the government affairs, you're going to hear from Peter in the morning, we are one of those committees. So that is our home, and that gives us kind of the footprint from where we can operate. Does that answer your question? So ACM, like IEEE, is another professional organization that also has more of an international footprint. So we're very North American biased because of the National Science Foundation funding. And so we try to cooperate and play well with those professional organizations. And Tom is here, so Tom very much leadership in IEEE around the rebooting computing effort. So we made sure to link that into our activities around future of architecture and post-Moore's law. I'm more of an ACM person, so I've been involved in trying to bridge those, but think of that as kind of opportunistic organization building. Thank you.